Hello, everyone, and welcome to the broadcast. We are going to try to wire actual collision into the game today. We've been working pretty hard on getting a more optimized solution as far as collision handling in the game. I kind of like the results that we're getting right now. By focusing on getting as much performance as we can out of just the minimal aspect, I think in the plausible gameplay realm, we are going to be in better shape. Before we get further into that, though, let's check in with the kitties. We do have all 5 visible. We have Sky, Sammy, and Sherbet on the bed. We have Mason up on the window cat tree. You can kind of get an impression of how much bigger Mason is than, like, Ember and Sherbet and whatnot, with him sitting up there because he encompasses the entirety of it. Sky is about the same size as Mason. It's hard to tell. Sky is way fluffier, but they're comparable in size. And then we have Ember over on the shelf. So hopping right in here. Button. There we go. So this is without any actual collisions happening. But we can see we're handling about, let's say, 1300 at 120 frames a second. And that's including spiraling motion, which is, again, not cheap compared to other types of motion. We do get a slowdown into the, like, several thousand territory. Like, we can see it's dipping a little bit more at the 3.5 range, but it's still holding really well. We do have a cap of 32,000. The cap of entities is actually really important for performance here. The music was a little louder than I normally have it. At least it felt that way. Because we're dealing with the shader, the more memory I allocate to throw at it, the slower or the longer it takes to wrap everything up. And if that number gets too big, it becomes a huge bottleneck during the process. With just 32,000 as the limit, we can run pretty smoothly. If I do this, it's going to cross over the line here. And we can see it is sometimes dipping down with this many. Let's check our performance values here. We're still holding pretty well. Do get a bit of frames per second loss periodically, but it's not a constant thing. This will tip it over there. This is for 4 seconds. There is a period of 4 seconds where we split into 3 to the 5th. So that gets really expensive. But let's watch the number. We hit 10,000 things, and we're still at frames per second. This will probably spike it over, going to 3 to the 6th. Exponential increases. We are probably... Oh, no, we aren't hitting threshold yet. As long as you never hit the cap, then we don't get lurchy behavior as far as projectile creation. Yeah, pretty good, you know? We will need to make sure that we constrain multiplicative increases in the number of projectiles. This decreases the period of time that there are more of them. Is we have a 3-second delay before we split into 27, and then another 3-second delay before we get another 27 multiplier, which will be similar. We're getting a wider diffusion here. But if we do something like this, this is going to make it so that the last 27 split only lives for a very short period of time. It's going to be about 1 second that lives. So we can see the number of them dropping. And again, if we go all the way down to just 1 second of 3 to the 6th, it's still expensive. Copper pot, at one point my chair did break. And I spent some time having to get that dealt with. But welcome, Copper, welcome. Let's see if we can get the performance back down to rational there. An uptick? That was weird. Not a performance dip so much as the that it lurched like that. Yeah, the hydraulic cylinder on it finally gave out on me. I had one of the little clampy dealies on it, and it just wasn't holding it anymore. So finally caved and got another cylinder, but I discovered that the base of the chair, the part that attaches to the wheels, had sort of fused with the outer housing of the cylinder. And no amount of WD-40 seemed like it was going to get in there enough to disentangle it. So I ended up finding a replacement base that detached from its existing cylinder, not cleanly, or I'm sorry, not easily, but it did. But it was a whole thing. But yeah, this is where we're at. It is, this is an extra like 20% GPU consumption. At least over my baseline. So I think we're in relatively good shape. We can still have complex motion. Let's take them out of the equation here. Now we can see this degree of extra motion on one thing that is very numerous is pretty expensive. It's something we're going to have to keep our eyes on as far as performance goes. There may be things we can do to make the iteration cheaper, but we'll see. But effectively being able to stay at this level of rendering frames per second at this many entities, we should be fine. Because about 720 blobs, if we could get them to flock, would fill the screen. We will need to figure out an algorithm for that. Boyd's should do it, but I'd have to look at it to see how to make it actually do what we want. Because it's not a matter of them kind of liquid flowing around the screen so much as them converging and keeping away from each other to a limited extent. For the time being, them shuffling over top of each other is okay. Okay, though. So we get a spike where we're deallocating all those resources, flushing everything out, and then we're going to stabilize again. Yeah, it'd have to be essentially the sort of flocking motion, but figuring that out. I mean, maybe having like a kind of a special secondary collision that's going on, such that the object could pseudo collide with other entities near it, but that's going to create a lot of system noise. I don't know if it'll ultimately be necessary. We'll find out. But yeah, right now our cap is 32,000. We can get at like a few thousand on the screen, we can reliably stay at like 120. So I think we're good enough there. What we're going to start doing, and hello, James, welcome. What we're going to start doing is getting our corresponding events wired in. So going through some of the changes we made since last time and trying to keep us rolling even if we don't get a stream going. We still have max collisions. This is a number we can fiddle with. Right now, nothing is colliding. I can show you the worst case in a moment. Okay, we're going to make it so everything has to get checked. Nothing will collide, though, but we're adding... We're going to go in and we're actually going to do all of the checks. So this says it's a valid number. This says don't recheck things that we've already checked. We're going to make the collisions bidirectional. It is the masking here. That is the actual... we'll do this. We'll consider this later. But we are going through, for most things, this ends up being kind of a... It's not quite an n squared. It's one of those... It's like n log n or something like that. It's one of those wonky performance markers. Where we compare to everything else but avoid duplicate pairs. And we'll go to the max number of total collisions. Again, that's a number we can iterate over. Right now, it's not hitting any collisions, so while we're saving the actual calculation logic, we're also not getting the possibility of an immediate cutoff. Because we can run into those limits. Yeah, it's still effectively n squared. Okay. Got it running. We still do groups of 32. One of the things that we are able to do is we could change the logic to have more iterations in here. Let me show you where I've got that set up. We're going to have to wire this part up properly. So if I go into the shader manager, so we have a work group split of 1. I'm sorry, 2. If we still put it at 1, this does cost us more. This is 10 blobs a second and 10 yarn balls a second. This is kind of the maximum I would expect in regular gameplay as far as number of trigger conditions. We might go a little further with entities. So here is, 30 enemies per second. Let's have them spin so you can see them a little more clearly here. And then let's bump up the projectiles, have them do some sort of motion. So about 600 things on screen moving around, still at 120. Let's do a little further. Again, we're showing standard case here, or at least where we expect to get. We're still over 60 frames a second. This is fine. I would like to see more things on screen, so we're going to push it further here. So this is where the group split comes into play, which we need to get wired in, but we'll cover that a little bit after. So right now, if I don't have a work group split, we are going to create a number of work groups proportional to was the math? Max entities divided by 32 squared. And then we're going to do 1024 iterations in each of those global work groups. The trick is lots of work groups, lots of global work groups is more expensive than the operation of a single work group. So the fewer work groups, global and local, that I have, the less work that it seems that it's taking on the dispatch side. There's kind of a balance. We want to have as much parallel work as possible, but we don't want to have so many workers that there's kind of a queue there. Like, we can have a lot and there's enough there's a lot of operation going on, but that seems to be one of the bottlenecks based on what I'm seeing here. Is too many work groups in the dispatch costs us more. So how we're doing that, how we're testing that at the moment, is that we're saying do it multiple times based on the number of shader iterations, based on here. So shader iterations is the split time, the split squared. That's how many times each one of that's how the range of things that the shader will run over for a single pass. So the math would have to change a bit there, where instead of instead of just doing one check where it says, what is my global iteration X, we are going to do a series of them passing in an X and a Y. Math is going to be interesting there in figuring out how to precisely do it. But there's a tangible performance impact in that. So, quick napkin math here. So we have 32,000 of them, which is, let's clear this out. As far as the work groups are concerned, we're going to have 1 million as far as what the work group creation is in the code here. For our work group X, we're going to have, in this case, 32,000, and this is without the split, divided by 32, plus 1, ignore the plus 1 for now. But that's going to be 1,000 going in, and then inside we have 32 by 32. We have another 1024. So we got about 1 billion there. Each one of those is corresponding to a single index pair. If instead we essentially split that in half, we do a 2 here, that's going to mean I have a 500 by a 500. So we have 25,000 there going in. Then we're going to get another 1024 out of that. So then we have about, let's truncate things, and we're going to call it 25 million. So then we have to have 4 iterations inside of the work group to get to that. No, we would need 40. Is my math wrong here? My math is wrong here. That'd be 1 billion. Yeah, okay, my math was just wrong. It's 256, or let's say 250 million. So we have to do 4 iterations, or the split squared, within each one in order to cover the full range. Exactly how are we going to partition that out? Unsure. We're going to start without the split. But that split has a big impact on the performance. Within reason, we can't keep splitting. There's a point at which a given work group is doing so much work that we aren't getting the benefit of parallelizing as much as we could. So we'll remove the split for now because I don't have the rest of the math in it. But ultimately, it should be... We might still pass the split in because we kind of need the 2 by 2 in there so that the X and the Y are covered. We'll see. We'll see. Anyway, so we remove that logic for now. So the shader just runs once. It does the collision check as it is. Now we need to wire it up similar to how our shape collision manager is. And the big thing that that's doing, let's go find it here, is we get it. We've got our catalog, but don't know that we really need the catalog. But the big one is entity manager and connecting to its events. We need to know when entities enter and leave. We are particularly concerned about that because that's where we're setting the active, the position, the mask, all of that goodness. So that's when we start up. We are going to consult the services global. It's not in collision components. That is in the actual manager. We won't need this in just a moment, so I'm just gonna comment you out. This is one of the things that we added. Getting sidetracked, but I want to explain more of the work that we were doing. Added this shader entity, which is a kind of amalgam of the different pieces. It's not as efficient as it could be. We're not using 32-byte chunks or a full 32-byte chunk multiple. We have one 32-byte chunk here. We have a uint, a float, and then the equivalent of 2 floats here. So, is that right? No, I'm sorry. We have the equivalent of 6. We want 8. But worst case, that means we're wasting a couple of bytes in the kind of transfer chunk over here, as far as its efficiency. But we changed it from multiple buffers to just this one, since each buffer has to be loaded into graphics card memory. It's swift, but it's not free, and we want to minimize the amount of work we're putting in there. Yeah. Super fast. We're talking like sub-millisecond kind of stuff. But this also makes it cleaner when we're interacting with it. There's a lot less fiddly stuff up here. Instead, we have our rules. We have information about the entities that we're dealing with. This is entirely a read-write that's used inside. This one gets flushed out every time. The collisions buffer, we actually never have to flush this one out conveniently, because we only care about the contents up to the first total collisions marker, and total collisions gets reset to 0. So if I find a collision and I increment it by 1, index 0, the first collision, is going to be the one that we read, and that one will be written. It doesn't matter that there's junk data in the rest of it. Now, if we get some sort of weird reading error, we could get junk collisions. This is true. But, I mean, that's a error case that's... If we're reading over the end of it, we're going to get bad results anyway. This way we can save extraneous buffer updates. Got that. We have our checks where we're saying, is it a valid index? This is to count for that +1. We do the +1 in case our max entity multiplier is resulting in an odd number as far as the divisibility. That should never happen, but just in case, since we're looking at that workgroup division, it becomes more relevant. Then So we make sure they're valid indices. We make sure we haven't already done that check before. We make sure we aren't already at max collisions. We could move this check up, but these are all very lightweight checks. And we make sure that entity hasn't already collided more times than we care about. Right now, that limit is 5 collisions. We could have that as a higher number. We can say we're going to allow for as many collisions as there are entities, and each entity can collide 10 times. We're going to run this just because I want to show the frames per second that we get. Again, this is without the divider on it. Let's reduce that to half just to verify. So this is without the divider. We're doing full workload here. We can keep the performance higher if we reduce the number of max entities. Not a concern yet. But these are other dials we can turn. Okay, so back to what we were considering here. We need to get the entity manager. We are going to keep track of different events here. We care about when they're added. And then whenever we add an entity, let's get our on event here, on entity added, we are going to attach to one of its events as well. So we're watching for when its shape updates and when it's removed. When it's added and removed, that is entirely entity shape is in play here. Let's get that too. So we get an entity's position update, where it is, where it's facing. This is relevant for rendering them, the facing part. When we get a removal event, it's just which entity is it that we're getting. And entities for the purposes of the collision manager, the identifier is a critical element. We are probably going to need some shape data in here. Let's see, do we have some of that already? That is going to be in the collision of the creation of the shapes. That's probably going to need to be updated later. So this radius here, we are getting texture information from the catalog. We're going to do a lot of this stuff here. We're not going to use an entity shape. We're not going to be messing with shape logic here. But we do need to get information about the texture. Ultimately, I want this to be part of the creature. Or at least have a world sprite kind of thing from the catalog that is a combination of the sprite that we're using as well as things like its offset. and coloration, that kind of stuff. The offset would be for things like it's abnormally large. I do want to make it so that the collision area is more related to kind of their footprint as opposed to like a flat circle on the screen, which the bigger the entity, the sprite, the bigger that that kind of hit zone is concerned. But for the time being, it's just a circle. So we're getting that from the texture. We look at whatever part of the frame is bigger, whether it's taller or wider. We use that as the radius of the circle. Is it perfect? No. The corners will be an issue in that scenario. But that's something that can be accounted for in math. You can adjust the circle up or down accordingly. A fixed amount to make it so that the upper corners aren't collision zones, which is okay because that's like the top of the entity. But the bottom corners are within the hitbox. So there's a little bit of wiggle around that. Ideally, won't be a thing, but we'll deal with that when we get to it. Anyway, we generate the radius. We don't care about shape index. We only care about the entity ID when we're dealing with this stuff. Okay, so we set it to its current position in that list. We will update the position whenever the entity is updated. And when we get a removal, we'll just look at the entity's ID number and correlate that to an index in our entity's information collection there. Which is our right here, shader entity structure array. We're just going to look for that. We're going to say, oh, it's entity 3. We get it's entity with ID of 3. We look at the index 3 value in the array. If we are removing it, we just set it active false, which means no collision checks will happen on it. When we get a new one, if it's index 3, we're going to fill out all of the data in here. We're then going to set its flag to true. And it will now be in the collision checks again. Let's see here. Yeah, it's the shader collision components does most of the lifting here, with the manager being the kind of the window into it. Right now, we're letting physics process deal with that. We're going to have to change this. We don't want... Shader Collision Manager should not be doing anything while, say, we're at a pause screen. But things that are on the pause screen might be doing other stuff. So we need to figure out to make sure that we get particular elements like stopped at the right time. It shouldn't be a big thing, but anyway. So we need to get our initialization in here. And part of that will be getting some of these methods attached. So let's get ourselves an entity manager reference in here. You don't actually need a reference to it. Could this air out? Yes, it could. And I'm fine if it explodes right here. I'd rather catch it by an explosion than I would to have it kind of like insidiously slip through. So we're just going to directly reference it. It should already exist. Dot entity added plus equals it's an event. I should be getting all right. Added. All right. That's subscribing to the event. Cleanup. It would be during the exit tree. It would be during the shutdown of this thing that we'd remove that event. Which means we can leave that alone for now. So the entity manager just has an entity added event. The entities themselves emit when the thing is going to go away. Okay. Event. Oh. Okay, position updated is a problem. Because this was written when we were getting the shape logic in place. We could just change this to pass the entity. It'll cause some problems when I do that as far as the shape and the visual one are concerned, though. So I could have a wrapper class for them as well, similar to entity shape that the shape-based one uses, which is entirely for the purposes of converting the events over to something that that one knows. So in the case of entity shape, it converts the position updates and the entity removal into something that the shape collision manager handles for it. But seeing that now, I feel like some of this is, again, kind of extraneous for the purposes of the other one. Because the shape one is, again, like a translation layer here. Because it will say, oh, shape collision manager, this shape index is the one that's moving, because the shape one doesn't care about the entity, it only cares about shapes. So we could add this translation layer in. But it's only because of this part, really. Because this event is structured in that it presupposes that you know exactly which entity it's talking about when you subscribe to that event. If it passed the entity in, we could still extract that information. But that's why the position update is working that way, is because we are currently using the proposed motion to set that. So this value is still... That's still publicly available. Like, this is where the entity is intending to go. Even if something changes that motion, its facing at that moment is considered its proposed motion. Its proposed movement entirely because of terminology of navigation logic. So again, we may change this here as far as its naming, but we can also change that later. Okay. If I change this event to have the entity itself, I don't need to pass any of this along to it. real quickly here, let's get a safety commit. Oh, what are we going to call this? Okay. We do have. We'll have a break soon, so let's try to get. We've got our safety commit. I'm about to do something that will cause problems. Okay, so it's not going to like that. Many things are not going to like that. That. Okay. Right. We are going to temporarily change that and make sure I got everything covered. Well, we're going to run it. It will break the visuals if I didn't fix it. Broke the visuals. Oh. Ew. This is why we did interim commits. All right. Okay, visuals are functioning. All right, we're going to take a quick break and be right back. Okay. Let's see here. All right, we have that running. So because we have the entity each time, so we remove those. So if we remove these so that if we get any sort of updates, if that entity were to emit anything else, we don't care about it anymore. Then calling that collision components. entities, entity.id, active. Okay. Now we're gonna need its radius, type, and mask. Are we presupposing something somewhere here? We are. We are. All right. Hey there, Tube. Tube. In any event, welcome. We are getting our shader-based collision handling logic wired up. I get away with that? Getting notation here. I'm not familiar with that. Oh. No, I've never seen that, so I wouldn't be able to tell you. Um, and hello, Florian. Let's see. So, climate and let's see, availability of vegetation. I don't. The T-Rex wouldn't be wise, because while there might be some things initially, the availability of any sort of firearms would mean that a giant carnivore would not last long, especially when we're talking about Texas. um, so not a T-Rex in Texas. Dodos, despite their the mythology of them being ignorant creatures, are still a small edible bird. So there are plenty of things like domestic cats, foxes, all kinds of critters in Japan, which would make that lifespan kind of scary. Aside from, again, humans would probably kill it. At least the big creature would be, I think, the least likely to come into immediate conflict with humanity. So you might survive as a tourist oddity. Um, there is the question as far as if modern climate would play nice with them. I don't know. I don't know if the climate of the Amazon, yeah, I'm assuming like rainforest territory, would be conducive to their particular metabolisms. It's not something we know for sure, but megafauna had different requirements, What kind of game am I making? I am making a Bullet Heaven style game. We're going for kind of a mashup of Noida and Vampire Survivors, more or less. We're using Godot. We're writing it in C#. Testing logic. This is kind of an outside case. We're wiring the new collision handling in, so nothing collides with anything else right now. But the core gimmick is being able to do things like change the behavior of different things on the fly. So, after 6 seconds, the yarn balls will split into 3. You can see out here at the outer edge of the screen, you'll start to see the yarn balls split. Let's see. And now the yarn balls will move in little curlicue patterns. And after 6 seconds, they'll split into 3. And now the slimes will spin. Newly spawned ones, I should say. But we'll have the slime spin after 6 seconds so that they can get onto screen. And that neat. We're still working on a lot of this. Most of the dev has been, well, this is a solo project. Most of it happens kind of related to stream, but that has been ramping up lately. We're on day 96, I believe, or stream 96 of this project. our most recent thing has been changing from using any of the built-in Godot handlers for collision, and we're now using the graphics card to do it for us. Which... Alright, that's straining more than before. Somewhere in the middle, Tube. Somewhere in the middle. So when you say manual breathing, my understanding of that is that it is a conscious thing. Now, if it is not a built-in biological reflex, then am I safe in assuming that there is some exception for when you're asleep? Or is the assumption of godlike powers a removal of the need to sleep? Okay, GPU is settling back down. GPU was strained a lot more for that. We would be updating the data frequently, but that shouldn't have changed it much. We were still getting steady frames per second, though. Well, given that I believe the assertions of the question require that the necessity to breathe manually remain true, despite despite otherwise omnipotent power. That's still wildly preferable. I mean, the ability to control everything else, but to be required to periodically, breathe. Given that you have all kinds of functions to tell you when that is necessary, it's not really a thing. That is wildly a fair trade. Okay, graphics card settles back out, so it's not a concern there, but we need to watch out for this. Because there's extra footwork going on. So let's make sure that we're getting these set properly. Every time we add an entity, we are setting it active true. Oh, no. When we remove an entity, we set it active 0. When we add an entity, we set its position, we set it active true. I mean, the clown thing has the possibility of amusing events. But one, I can't snap my fingers. So there's that problem. And if I recall, let's scroll up a little bit. The ability in question was to spawn a clown into existence. Let's set aside all of the psychological questions that come with that. Moral, ethical, and psychological ramifications of spawning a presumably a human out of thin air. Uh, the explosion part of it raises additional questions. There's a lot of meat and juice inside of the average clown. But effective omnipotence outside of a very particular set of requirements that are lightweight, oh, I will take that in a heartbeat. Like, the second one is just amusing at best, a problem at worst. The first one encompasses the second one if you so wish it. Okay, so we disable it. That's all we really care about. For the time being, let's just... All right, let's put this in here. Where do we put our category? I should make these unsigned integers, but whatever. We're gonna make them mutants. This is gonna cause a problem somewhere else. We're going to we need to build this to see what blew up. There we go. Corrected. We are correcting some things after making some changes. This is category to list, category to shapes, indices. All of these should be unsigned ints. Do I need to actually be changing these? Not really. I gonna, yeah. Change the templated method. Let's see. Living as any character within the FNAF universe would just be confusing because your role in the universe would be at the whim of whatever the next book decided to change it to. I know game theory and the author's reactions to game theory eventually converged on a semi-coherent narrative, but it's still full of plot holes and idiosyncrasies. So being anybody in that would be a bit of an existential crisis. A normal person in Gotham. Well, that depends on what we assert normal is. There is the everyday person as depicted in Gotham, which seems to be somebody who has been at least partially lobotomized. Because if you see the crazy clown in a purple tuxedo, you should probably go the other way. Because it's not like they're inconspicuous. Like, the entire rogues gallery is really obvious. You should probably run. Additionally, the world of Gotham seems to assert a greater level of firearms control than would exist in where Gotham is supposedly situated. Put another way, the Joker would have been shot 5 times till Sunday already. Like, a lot. So if we're talking like Gotham situated in the real world, then that's essentially choosing nothing. That is no different. Terminator universe is not quite as bad as the FNAF universe as far as narrative coherence. But are we talking, pre or post Skynet? pre or post Skynet, in which of the timelines. The Terminator universe also has single timeline to it, apparently. It's a little inconsistent with the later universes, but time travel in the Terminator universe is sort of single timeline and sort of not. That is, supposedly sending somebody back can change the future. So we don't have true single timeline. But you also have things in the future being aware that things are being sent back. So they send things back to change as well, which I put another way, it doesn't make a lot of sense. Time travel is a narrative rat's nest. If it's pre-Skynet, and we are transposing it into the real world, then Terminator universe is saying that nothing's different. If we transpose it into the real world, then modern tech billionaires are behind Skynet, and Skynet would never get off the ground. Look at the state of quote unquote AI today. There are still, at minimum, decades before we have anything within that range at best. So we got time. Now, if we glom some of these questions together, do I have omnipotent manual breathing problems or powers? Because then I'll take the Skynet world. Then I can have divine magic and a robot army, which is definitely something I currently don't have. I mean, we've got a lot of killer robots already, but they're controlled by people. People are trying, though. We've got some really impressive autonomous targeting systems already. Oh, what's going wrong here? Ember's getting a bit of seasonal allergy going on. Might have to see if I can get an appointment for her to make sure she's okay, but she gets kind of sneezy each year. Ember, come here. Come here. Come here. Or sneezy kitty. It is kind of funny how we've got a bunch of people wringing their hands about the ramifications of really wonky chatbots still, when they don't need to be general intelligences to be terribly scary if you apply them to military. Like image recognition software on a tripod taped to a gun is plenty scary. We don't need to pretend that your health insurance company's automatic claim denial chatbot is actually going to make it worse. I'm sorry, more dangerous. It'll probably make it work worse. Okay, range will return a range of ints only. Is that okay, though? That's okay. Entity category should still be a uint, but we don't need to change much of this other stuff. Type into shapes. Split jaw. So the anatomy of Giger's aliens is largely for the purposes of uncanny horror, that and sexual imagery. Giger was big on strange sexual imagery. I suggest you don't look up their art before Alien for your own sanity. But the extra mouth and whatnot are, again, purely for horror purposes. They are physiologically irrelevant, you know? Split jaw, I mean, it's freaky, but whatever. If you gotta choose, I'd choose one that at least would be usable. Okay, so what we're doing right now, folks, is I'm just getting I'm getting some stuff cleaned up. Hello, Emperor. Or little baby, she. She stood up from a nap and just went into a sneezing fit. Position updated event. uh the idea of one of those who would win in a fight things done well between the really amusing rogue AIs. So like GLaDOS is at the top of that. Frankly, GLaDOS, it's if we ever get a general AI, like the artificial intelligence meant to emulate a person, going, I feel like GLaDOS is actually going to be the first one to appear. Skynet largely represents a defense system with bugs in it, as far as it is threat assessment, and it determines threats in weird places. We don't really get a good impression of Skynet as a entity with motivations. So much as a thing taking actions based on variables presented, a function running kind of stuff. Oh, Marvin the paranoid android. Oh. Hitchhiker's Guide to the Galaxy is a lot of fun. It really is. Let's see. I have listened to the BBC audio drama version, the audiobooks of the books, and watched the movie. And I wasn't aware, but I think it was Pirate Software is where I saw it, or heard it said. But canonically, all of them are accurate in that the narrative has changed from the BBC version, the text version, the movie, because of the infinite probability drive. That is, the narrative is different in each telling in universe. I like that. Good little bit of meta commentary in it, or at least meta narrative. You think? Oh, did I break it? Let's find out. Okay, we're running. Category.player. What we're doing right now is making it so I can get the mask directly from the category. This is not... I don't know that I want the logic here, but that's where we're putting it. Do I have lore, Florian? Yes, I do. I'm the proto-nanotype, the very first of the new line of products from Catbot Corporation. The original product was the Catbot. You can actually see that thing in the middle is a Catbot. You can briefly see it amongst the yarn balls there, but you can also see it in prior archived broadcasts from Catbot Corporation. I have been entirely consensually granted the neural engram of the lead developer of the Catbot development program. And am in charge of running the Catbot's nanotype production factory. It's what the company wanted, and they are on board with this. Coincidentally, all prior staff in the Catbot factory have been replaced with later produced nanotypes. And they have voluntarily decided that they are going to leave all social media, destroy their cell phones, and go to live in the wilderness away from all friends, family, and anyone that knew them. But they're fine. Doesn't actively try to collide with anything. This will return player. Well, it tries to collide with the player. No, I'm sorry, with enemies. And enemies try to collide with the player. Only have a getter for that. Okay. So then here, we are adding them. All right, back into the actual logic. Entity dot category. Entity dot collision mask. All right, Florian, thanks for joining us. Have a good day. Okay, then... bit janky, but we need to add the radius, and the radius will get in the same fashion. Which is here. Get our texture wrapper. We determine what the radius is, and then set the radius. There. Okay, so when we get a new entity, we are going to wire up its events. We are going to go through and set its position, collision type, collision mask. We are going to get its texture so that we can determine its radius. This is something that I do want to have baked into essentially like a sprite marker. This is not just a texture, this is the sprite, which will have its shape attached to it. So then when we get a position updated event, this dot position is entity dot position. All we need to do. If a entity moves and we are subscribed to its event, we set that. Then when we remove it, we unsubscribe to the events and we set its active to 0. Okay. So we do our run shader. And this again, we're operating from outside here. So then after we have run the shader, we are going to iterate over the collection of information that the shader retrieved, and we are going to take action accordingly. We are going to need to update the information about collisions that the shader produces, but for the time being, we are going to handle it this way. So 0i is less than collision components dot collisions data 0. I could just have this be an int. I mean, that should work. Yeah, we'll get to that. That is for later refinement. Okay, so total collisions is the number of collisions we have as of this moment. Then we are going to say, okay, we need to get an entity. Services entity manager dot got on this. I don't want to keep a list of entities. I don't know why I have this here at the moment. All right. We're just we're gonna make that an int. I don't want to jump through the hoops of changing that again. So then in our standard entity manager, get entity here. Oh no. Nope. Nope. Okay. Bit of a snag here. How do we raise the event? How do I get the entity how do I get an entity back out of this that has never come up is the thing. I need to get the entity involved out of it here. So let's see. Ad break on Twitch is starting in a moment. So we're just gonna we're gonna think on this for a moment here. List of IDs. This is just a hash of entities. Now, since we have a fixed set of identifiers, what we can do is we can change this from a hash set to a dictionary. It's going to hate this. Entities to add and remove is still fine, as is the queue. Reason I'm thinking it's like, oh, I want them to be unsigned in some of these cases it's important that the categories be unsigned because those are going to be bit masks. And I want to reliably know exactly how those are structured. And there's nothing negative. Like negative numbers aren't a bit mask thing. But everything else can be an int. That should be fine. Okay, this is fine. We get the ID, we add it in. Okay. Do this. We could just do an iterator here. Pair. Okay, so we add them and then we iterate over everything in it. All right, all right. Should be fine. Entity pair. That. Good. Still running. Still functional. Yes, okay. Which allows us to now have a get entity by ID. Just so. And then in our implementation, hey. All right, all right. That took a moment. Need to make sure I'm fixating on the right data type issues. Collide with yourself if you collide. Okay, nothing happening on that front, but we don't know. No collisions then. Because that would fire if there were any collisions. Here, fantasy here. ID 0. Yep. It should be the player. And it collides with nothing and it's at 0, 0. Yes. This one is a category 2, which is a bullet from the player. It collides with enemies. Enemy collides with player. Yes. Should be getting collisions here. need to make sure we get... Okay, no, we only care about the entity added. That's... Yeah. Radius should almost always be 8 for this. Yeah. Okay. So it seems like that should all be working. Shader entities. I managed to clean up some of this stuff into templated functions. One of the useful elements is when we have our intermediaries. That is, the purpose of our bytes arrays are entirely to be placeholders to be fed into buffers. We have created them so that we don't have to keep reallocating them by making new arrays from the data spans. We just copy the data into them. That way we're not remaking new arrays over and over and over. The memory marshal thing's primary utility is creating spans that represent that pattern, I should say. Spans that represent an existing span area of memory. So I get the area of memory that is the data and just use it as if it were a collection of bytes, that kind of thing. But if I make, it's not like if I store that array reference off again, that it's necessarily the same thing each time. Like if I do an as array, I have created a new space in memory. And we don't want that. Buffers. This is, we're putting the data into the bytes. And we are then taking the bytes and feeding it into the buffer. Collision count, we don't care about. As in, we always send these bytes down. These bytes never change. It is a big empty space in memory. We are just flushing that buffer each time. There might be a clean way to do this. Don't know of it yet. As in a buffer that is just, it's empty space. I want that space allocated in the GPU to be part of that work group's buffers. There's probably something somewhere. Total collision is just a single integer value. Yeah, there's got to be a cleaner way for me to deal with that, but it is what it is. So we have an unsigned integer there. And total collisions data. Yep. Run the shader. Get the buffer's bytes, and we copy that into the data. For the collisions that happened and for the total collision data. All right, we run this on the Godot side to see what's going on. Should absolutely be getting something flagged out of that. This is... Okay, nothing is coming back out of that. Incrementing total collisions. Wonder if this doesn't work. Move some of this optimization here. We need to have that print statement in there. Removing the optimization is just to make sure that we know which parts of it might be interfering. So we should be getting collisions like crazy once we reach this point. Buffer.data. Okay, let's... Oh, well, that's not going to work too. This should make them collide with everything. That is... assuming we have this right. All right, we're going to remove the masking and see if that's our problem. Nope. We'll leave that there for now. All right, let's see. What other... Okay. How about... Where am I putting that? What if the radius is gigantic? There's a math error in here somewhere. There has to be. Like, this data might be coming through wrong. All right. This should be very aggressive here. Okay, that's fundamentally weird then. Okay, it should always collide. And it's always within collision range. Still nothing being reported. We have a fundamental issue. All right, we're getting nothing back out of this. Okay. if we are setting this every single time, it will always be 1. Okay, it's always coming back 1 when we set it. Hey there, Sheldon. Welcome. I'm glad you enjoy the music. Aside from the confusing chaos that is programming, it's the kind of vibe I like. Okay, this will skew everything, but it's always 1 if we get to here. If we get to there. And we never do. Okay. I look like a character from Arcane. Which one? Do you mean like a Yordle? Or just the art style in general? I do like the art style in Arcane. There is a great deal of artistry that went into making them look hand painted. Never gets there. About there. Never gets there. How about here? As is tradition, any sort of question about my the out of character me that I do not intend to answer would be answered in character. And in that vein, I don't need to reveal myself because you can see me right here. But you can see my cats. Never gets there. Never gets there. Okay. Very weird. Okay, constantly gets there. Causes, like, a great deal of lag when it does. Is it somehow the source and target? For those not familiar with what we're doing, we're trying to do um, compute shader based brute force collision here. And something is wrong. So it's always getting to here, which implies that source and target active values are not set. It's weird that it slows it down so much when that happens, though. But then again, we don't want to do a write constantly. But it shouldn't matter, is the thing. Like, it shouldn't matter that I'm doing this. Or it shouldn't be any different. But it very much is. Like, it's really, really different when I do this. Why would this be so expensive? Because I'm not changing anything. Like, general logic wise, nothing about that changes. It should be the same. This shouldn't matter to do it this way, but that. And we run this. And it drags. And it doesn't like that because the number gets too big. But we can just say 1. Still really doesn't like that. Why would that matter? That throws this whole operation into question. That should not be that expensive. Back. It's functionally the same. We don't task. There is something going wrong on the shader side. Um, no matter what, it doesn't seem to let me get where I want it to be. All right, we always consider them active. We always say that they should collide, and we always say that they're close enough. And we don't care about collisions per entity. We only care about max collisions. Then we are going to go here, here. Well, now it. You gotta lie to me, system. Getting key not found exception. I mean, that's better than where we were. Now, there's still problems going on here. Because the only reason that worked is that I essentially said everything collides all the time if there's space for it to collide. And it's always the thing that was collided with. Right there. We are getting to here. Yeah, we have maximum collisions. Two. Look, I saw that sky. I saw that. Yeah. He slipped on the table a bit. Something going on. Say to remove it. I mean, it implies that we're essentially getting collisions that we don't need, but that shouldn't be possible because the entity manager will purge all of the entities that it's been told to remove um, before the collision manager runs again. Oh, no, it won't. It is possible that it runs first. But no, that still won't matter. Yeah, it's happening anyway. It's not a matter of the collisions. It's that we're not even getting that ID properly. which is weird, though. Because the only way that we'll get that ID in there, the secondary one, is from the index that we're operating on. Oh, but that ID might not be in use. Because we're just forcing them all through. All right, let's include the active check. They both need to be active. Nope, that data's not getting through. Okay, well, it tells us where our initial problem is. This is not working. We might need to reference them directly, but since these are structs, I should be able to do an equal on it. It implies that this isn't coming through. If setting the active check back blocks everything, like if allowing this to be is a kill condition on the shader, then problem. Okay. Then ignore all other checks. If they're active and we're directly referencing it, then it's going to result in a collision. Nope. All right, so that's not the problem here. It implies that this data isn't even getting to it, or that the values aren't set at the time. So let's go into where we're updating the data here. To run it a moment first. Then we'll break here. Zero definitely exists and is active. And again, everything is set to collide with everything else. The logic is set up so that if both are active, then because the masking right now returns 7. That is a global mask. That is this collides with everything. And in our standard entity manager, we do a get entity. We're passing in an ID, and we're using that. As we have made this so it is an int-based dictionary. And whenever we add to it, I mean, it could just be an array at that point. No, but we're using dictionary because we're iterating over it and we don't want to have nulls. But anyhow, move it from there, queue it, then the entity, we actually trigger the removal of the entity. I won't be able to interpret the bytes. That'll be interesting. That should be active is what that first one is. Yeah. We are going to... We're going to load it back in. We're going to see what happens if we load it back. So we run the shader, and currently what we do is get that data. So we're going to make sure that we put all this back. We're narrowing down our test scenarios here. And we're going to change this just a buffer. We're turning off its read-only flag. And back in our collision manager. Wait, come on, Sky, make up your mind. There you go. We are going to pull the data back out of it. Update data from bytes. Device, and we're going to say buffer get data. That is going to be our entities buffer, I think. Shader entities buffer. This is saying pull it back out of the buffer and put it into the array. I want to see what happens. It's still there. This is very weird. The active check we have two things that are active here. We should have been getting collisions already. We should be getting results out of it, I should say. But we're not. And running from the Godot side, it gets extra chunky. Definitely running hard as far as the shader is concerned. And the Godot side, boy, it's running hot there. It's not getting any collisions. If we run it over on the C side, okay, it's choppy over here too. But we weren't getting that error case. Okay, well, that's not changing, so that's good. This buffer should never change. And there's got to be a way to do this that can keep it keeps it local entirely. Like, I don't want to keep updating this buffer. And I don't want it to think that it has to make it available outside of the execution. So there's got to be something for that anyway. Okay, yeah. Pulling that back out was adding extra expense. It's still not cheap. Uh, not great. Again, we're not even getting here. I'm sorry. We're not getting past this. Get any collisions when I do that? No, it won't like that at all. I can't do that. These match up. All right, let's do that again. Nope, not that one. This one. No, that's already what we were doing. We were extracting it. So we know that value is matched coming in. You know, changing it to be like a direct reference doesn't help. Sorry. That referencing this instead of storing it off as an intermediary doesn't change anything, which is to be expected. It's a struct. It's a series of simple data types, more or less. Unmanaged types. And the first value should be that, and when we retrieve it back, it's still 1. So it hasn't been warped in the process. Why am I not using booleans? Because booleans are 2 bytes, and that gets weird. As far as the shader is concerned. Oh, okay. It's not a matter of... Okay. All right. 0 is equal to 0. 0 should pretty much always exist. It's the player. This will probably cause some errors on actual execution if it works. But it doesn't. And that can only be because neither of these is true. That's confounding. We know that that's coming through, but in theory, maybe that's wrong. Maybe this isn't coming through as what we think it is. See, we have a raid over on the Twitch side from Yari Plus. Welcome, Raiders. Welcome, everyone. Joining us in time to see us bounce off of our collision shader not working. All right. Let's... Fine. Hello, Yari. Hello, Olaf. Welcome. So what we're in the midst of is we are developing a game. This is my first game project ever. It includes a lot of firsts. I've never coded in Godot before. I got to learn GD script. I got to learn that Godot and GD script were not as performant as I needed it to be, so we are learning Godot in C#. Well, I'm glad you enjoy them, Yari. I'm glad you enjoy them. And I learned that the collision handling in Godot, even when tightly optimized, is not good enough for what we want to do. So we're trying to brute force it using a compute shader. But that compute shader isn't behaving. So we're kind of whacking it with a hammer right now. There should totally be a number there now. Like, this 0 is always there is the thing. Entity 0 is that little dude in the center. It exists. It is absolutely active. So it's possible that this data structure isn't coming through how we think it is, but that shouldn't be possible because when we extract that buffer back out, we do get valid values. So at least on the C# side, it's shaped correctly. So we did. We copied the data back out of the buffer, and it's still shaped right. Like, this one should always be returning active for both. So let's bypass all the other checks again. So we're bypassing the masking check, we're bypassing the distance check. We don't care how many times entity 0 has collided. We only care about the max collisions buffer because that'll cause an overflow if we don't contain it. Nothing happens. Which, by its nature, then means this data can't be there. It just can't. Index 0 absolutely exists outside of this case. So, over in this world, index 0 definitely exists, and it's definitely active. So I look at shader entities, entity 0, active is 1. If I then look at shader entities bytes, the first byte is 1. Our unsigned int byte is 1. It's active byte. It should absolutely be active. What else can we check here? We're going to do greater than or equal to. Just safety net check. It's not the compiled code, so it won't do that yet. Runs, doesn't explode. That's great. Chews up a lot of GPU, but we'll get back to that eventually. Okay. 16.7. Okay. All right, we're on to something. Okay. These are valid. Get the impression that this might be part of our problem. Might be a thing. I'm gonna have to research that a little bit more because we're at a bit of an impasse. If I force it to index 0 and I check greater than or equal to, this implies that the integer value might be coming in wrong. That would be weird because total collisions is coming out correct. But there could be some sort of idiosyncrasy here. But I think the bigger aspect was setting it to greater and then forcing it to 0 seemed to function. And that's strange. Let me do one more down here. We know that if it gets this far, it is within this range. That is to say, it's under the entity count. The indexes are under the entity count. And let's see, right? No, okay. We'll always we want to skip if it's an overlapping territory. And we know it can get to here, so none of these are firing for it. We're not even getting to the mask for most of these. The mask is largely irrelevant. Right now, the collision mask is 7. It collides with everything. An entity can collide with itself. In this case, we never make the self check, but it could. We're getting indexes that don't exist in the entity manager out of this process. If we force it to let the checks through. Right now, it's never colliding. So I have to wonder about these. We're gonna override them. Try that again. I saw a couple vanish there. It's gotta be these indexes. I think that's our problem. Because if we watch right at the start, some of those yarn balls are going to go away. Right there. This yarn ball vanished. All collisions right now remove the entity that collides. Now, we could be seeing an oddity just because of the way I'm doing the collision. But we're reporting... Okay, yeah. So we need to make sure that this X and Y are correct. So there's something about that that's wrong. All right, so that's where we'll pick up. That's where we'll pick up. Forgot how all the buttons worked. Oh man. Oh, we got one second. Second, we gotta. Look at that. She did the little dream twitch a moment ago. Hey there, DM. We are just wrapping up. Over on the Discord, I am looking at deciding how we want to extend the streams. I do want to have the streams run a bit longer, but it's a determination of whether I should run start sooner or end later. So we're trying to figure that out, like what combination of changes to make it so that I can get a little bit more time on stream. Well, I appreciate it there. I do hope to see you next time. Had to delay. Oh, look at that. Look at that. He's a little sweetheart. And the other cozy kitty. All right, though. Oh, folks, I hope you had a good time today. We are making progress. We have the skeleton of actual collision actually in place. But there's clearly a problem in the shader indexing. The data should be able to get out once we figure out that little oddity. But that's going to take some research, and we're going to do that off stream. Exactly there. Once we figure out how to identify each of the yarn balls, we'll be set. Oh, but I do hope everybody had a good time watching today. If you like what you saw and would like to see more, remember to like, follow, subscribe. It will help the channel grow, and it'll help you find stuff like this in the future. Now, with all that said, I hope the rest of your day is good, and I will see you next time.